you have to have the catalog, the bearing catalog. Now, in my course, in the course, I put already. I think about 3 types of bearing already. The standard HKS, AT, NTN, and then OP or something. And now normally you can find that also from the Google. Okay? No need to look it for before you have to go to the company and ask for the standard book. Because at that time we don't have the Google it's not so worldwide like this. Okay, so then it's not easy to determine the standard of the bearing at that time. But nowadays it's not a problem. You just go to the Google and ask for the bearing standard. Okay, they will show you any okay. Okay, that is for the bearing. Now this is the shape of the bearing. So then normally the bearing composed of three components. We have this one. It is the outer edge. Okay. We have this one also. It is the inner edge. Okay. And then we have at the middle here. Okay. That is the loading. Okay, loading element. Okay. So then for the loading element, you can have the shape like the spherical like this. Spherical. Okay, maybe single low, double low, anything. Okay. Again, you can have this one is the spherical. Okay. This one is also spherical. But with a small diameter. Okay? So then this one is spherical, but normally we call it the middle. Okay? Middle loading. Okay. Like that. And you can set also some taper. Okay, some taper. This one, all of it depends on the design of the company. Nowadays, we have also some bearing with the element, the shape like this. Okay. It is very forward. Okay, but now we have another new one that we have to shape something like this. We put this one. Okay. It is we call it this one. Is the shape size like the top. Okay. That we put something inside. You can see that they have something go up like this. Why they do this one? Okay. So then they do this one. Because of this reason, I asked this one to the SKF people, okay, why they have to design something like this. Because if you design the spherical like this, okay, like this one, so then the contact point is will be only the point, cannot change anything, okay, only the point of contact. If you design something like this, or like this, the contact point will be the align. Okay? Will be align. so then they do this one. Since the load is not normally not constant, it depends on. Okay? And when you can use this one to support the load like this, So then if you want to design some shape like this, or like this. So then you have to make so many type of so many side of the loading part, okay, for support different load. So then they do something like this. Why? Because when they I have to draw this one first. Okay. Now this is the race. Okay? The race. So then normally when you do the design, if you put this one, the loading part here, the contact point will be only a point. Okay, it will be only a point. Okay. If the load is not so much, if you hit the load, now the load becomes greater. What happens now? The top here, okay, this one will be go like it, will be flat. It will be flat due to the design. Because of high load, it will be flat. So then the contact will be extended. And they can support more load. นึกออกไหมฮะเขาดีไซน์เป็นรูปไอ้ถังเบียร์เนี่ยนะครับคือเหตุผลว่าถ้าโหลดน้อยเนี่ยจุดคอนแทคจะเป็นคอยเหมือนเดิมนี่พอโหลดเยอะนะครับยิ่งต้องรู้ว่ามันเก่งง่ายมันจะทำให้ตัวถังเบียร์เนี่ยค่อยๆแบกออกด้วยโหลดเวลากดลงไปพอแบกออกปุ๊บเนี่ยไอ้คอนแทคเขาก็จะยืดขึ้นใช่ไหมครับสามารถรับโหลดได้เพิ่มขึ้นเพราะฉะนั้นดีไซน์มาอันเดียวเนี่ยสามารถรับโหลดได้เรนจ์อันหนึ่งซึ่งกว้างมากนึกออกป่ะนะครับ not the same like this not like this because now for something like this we fit the capacity already we can maximum like this if you not use it to this maximum so then now you lost your money okay because you use to mix bearing okay so then this is the bearing and then all of this for the detail that you have to you can go to the even and you can use for the paper that I put for you for the bearing and they have the explanation in detail for each type of bearing how to use it okay that is the normally common thing okay okay now there are some special thing okay some special type of bearing that you can like this one or this one the same okay so then you can see that for this type of bearing they support the load on all the axis okay the load on the axis the bearing stay like this and the load come here so then you have the load here or something like this. So we call this one the truss bearing. The truss bearing. The bearing like this they use in the water power plant. You know that the water power plant for the dam, you have Glanky or Sinakrin dam or something like that. They use the bearing like this. Why? Because normally for the design of the power plant, the water power plant, so then you have the tube, so then for one side of the dam, you have the high level of the water. Okay? then the water go to distribute and down to the turbine down. Okay, so then to increase what? The velocity of the water. Okay, they change the potential energy of the water at higher level to become the velocity energy when they contact to the turbine. So then the turbine will, since the water come like this, and the turbine have to rotate in this way. Okay, so then the shaft will be stay like this. Okay, they will have a very long shaft, about more than about 10 meters something. Okay, and then this shaft and the turbine blade will support by the thrust bearing. Okay, so then this is the where they use. Normally, in automobile, in automotive, we don't see the thrust bearing so much. I think that we don't have the thrust bearing tools. Okay, in automotive. Okay, so then there needs some special use also for this type of bearing. Okay, now this is the thrust. This is the thrust bearing that I showed. You can see inside. Okay, designed to take on thrust load only. Therefore, they can take little or no radial load. Radial load means the load in this direction. Okay, the load in this direction. This is the radial load. Okay. So then they cannot support it. Okay, they cannot support it. It is the mounted bearing. Okay, that you know this already. We have the mounted or the pure block. Okay, the pure block, something like this. That you put the bearing here. You can see this is the bearing inside here. And then we can fit this one to the surface or anything. And then you can put the shaft here. However, you have to understand. For the bearing. Okay, this one. The bearing of this type for the inner leg, this is the inner leg inside here, and this is the outer leg. Which leg is fixed and which leg is turned, this rotate. Normally, we used to see that the inner leg rotate with the shaft. Okay? And the outer leg is fixed to something, okay, to the block. That is quite normal because nowadays we have the motor. But at the wheel is different. Okay, you have to know what the wheel of the car, because for the automotive today is the power to rotate the wheel come from the shaft. Okay, come from the gear. But in the past, for the carriage, you know that the horse carriage, you can see from the picture. Okay, you see the wheel rotate. At that time, the shaft is fit. You understand? The shaft is fit because the power is come from where? Come from the horse. Okay, that they pull the carriage like this. So then the wheel is to facilitate the movement of the carriage. So then the carriage rotates like this. Okay, but the shaft is fit. So then now in the outer leg that rotates. Okay, but really in that time, we don't have the bearing like this. Okay, we don't have the bearing like this. without contact to the surface of the element measurement. Okay, I say already, outer layer, inner layer, and spherical or unical rolling element. And now today we have the hub type. Okay, rolling element also. Advantage. Okay, this is direction. Restriction. Restriction means will be this means more efficiency. Okay, the loss is minimized. Okay, easy to duplicate and maintain. Lesser amount of duplicate use. Okay, this area require can support cycle. Noisy when damage present. So then this advantage one. Why disadvantage?
You know there's a fault.
Yes, we are warning. Okay? Warning on first that your bearing is something wrong. But understand first, if you can hear the noise from the bearing, the damage is great now. And you can hear it now. Okay? If you can see from the picture, the movie, you can see that some people they use some in the past. The people, the mechanical engineer, they use some equipment, okay, to touch to the engine and to hear something. Okay, this will help them to understand, to see, to hear something like this. It's caused by the bearing. Nowadays, what we have the vibration coming. Okay, the vibration. I think that if you will go to work, maybe in the automotive industry or any industry, you have to know two more things. Is the vibration monitoring. How to monitor the failure of the element, okay, by the vibration. Here, that is something important. Second, you have understand about the failure analysis. Okay, when you if you go to work as an engineer, what is your work? Normally, to work or to work. Okay. Design, okay, maintenance, and production. Okay, for the engineer, okay, production is the first that you will go to work with the machine and the production. Okay, and then when the production become wrong, okay, something wrong with production, this means that we have the problem with the machine, with the equipment. So then you have to ask maintenance engineer to come, okay, and diagnose, okay, what is the problem. After that, the engineer will be maintenance engineer will send this consideration to the design engineer to correction, okay, the design, okay, of the machine. It go like that. Okay. For the first start, the machine is designed by design engineer, okay, and construct in the workshop. At that time, the engineer design from what? Investigation. Okay? You have to think that what will be wrong in the future, something like that. Okay. In that case, you have to study something about failure, FMEA, failure analysis. Okay? First, what is the possible failure that will occur? And then you can do the design to protect that, to prevent that. But however, it will not be complete. Okay. If we have something more that will cause the failure of the bearing, of the movement. So then that you have to do the correction all the time before you can get one that is a good one. Disadvantage, important thing, expensive first. Okay, expensive. Need more area along radial direction. What does mean? Need more area. Okay, so then we need the shape. Normally, the loading bearing is something like this. Okay, so then when you have the radial load, high loading load, so then the side will go like this. Okay, it will go like this. It's not go like this, it's go like this. So then sometimes you don't have space now. Okay, for the bearing that to big like this. Okay. Expensive. One bearing in the cement company. Okay, cement company, SCG. Okay, the price is something about in the order of 100,000 baht. ตัวเป็นแสนนะครับแบริ่งที่ใช้อยู่ในโรงปูนเนี่ยตัวเป็นแสน Okay, the size may be about 1 meter minimum, or bigger than that. Okay, and then there's a measurement from some material to resist to the powder of the cement or something. Okay, that we go to touch. Okay, otherwise you have the corrosion or something. Start earlier. So then it's really expensive. Noisy. Okay. Due to the contact. So then when you rotate, this will rotate at high speed. You can hear the noise also. All the time. Okay. Shorter working life. More expensive, but shorter working life. Expensive. Because for the big shaft in GAT, okay, in GAT, they always use the journal bearing. They don't use this one, it's too expensive. Okay? And also, one thing important, when the big bearing, rolling bearing, damage, it's not on sale on the shelf because the size is very big and expensive. So then you have to order for the new manufacturing. Okay? That may take you a month before the new bearing comes. Okay? So then you have to forecast first when you have to change this bearing. Okay? So then it is something important. This some brief for the bearing type and how to use it. Okay. I think that for your examination, okay, or for your focus, normally we use only the first one, single low drift through bearing. Okay, because why we use this? Because I think that the standard that we have not cover everything. Okay, not cover all type of bearing, of rolling bearing. So then no problem. Normally we will not ask you to select the bearing type. Okay, so then you open your textbook or the catalog that you provide for you. You just only have this type of bearing, the first one. So then you can use this one for your homework or for your examination. It's not a problem. Okay? So then, but however, for the real bearing type, you have many type of it. Okay, and that will be put in the bearing handbook. The bearing handbook size about something like this. It's not so many certain type. And the first page about 20 pages. The first page. Then you talk about the bearing type and this type match to what use. Okay, what is can be used? What type? So then you have to study that first. But that's not a problem. If you go to work in the company, that do the design. So then, for this one, okay, you can consult with your senior for the start. Okay, and after that, if you have more experience to design this one, you will become more comfortable. Now, basic rotating. This is the term that you have to learn. We have one thing, basic static rotating, C0. Okay, CO. This the radial load causing combined from head of loader and base equal to 0.0001 multiplied by ball diameter. Okay, so then this is the design from the bearing company. Okay, for the deform, you understand that. When you have the ball that go on the race like this, the loading element deform. Okay, it becomes flat and thin. Okay, and then you design already that if the flat is in this range, not more than this, be still in the elastic limit. Okay? This will not cause the permanent deformation. After this loading element pass the contact point, they go to the middle shape. They go to a sphere again, or helical again. No flat part. But in case that, if the deformation is something more than this one, more than this. Now you risk to have the permanent deformation. It means that now your body element will not work properly. You can have to get the noise down. Okay, so then we need the reason. One thing, if you go to work, right in ICAT. Okay. You know ICAT, right? Cross factory ICAT. When they do the maintenance of the turbine, they take the turbine off. Okay? And they have to put this turbine on what? To have something to rotate the turbine slowly. Why? Because if you put the turbine, okay, what they put, they have the one cross like this, and you put the turbine, you put the shaft here, okay? So then now your turbine shaft with the turbine is a beam, okay? And the load will go to the bearing all the time. So then, if this turbine not rotate, what happens? It means that the contact point will be always the same point. So then they do the rotation. Okay? That means that they try to distribute the contact point to all the elements. Okay? And then they reduce the risk for the permanent deformation. Okay. Second, we have the C, term C. We call basic dynamic load rating. Okay? C is radial load causing L10 equal to 1 MR. MR comes from million revolution. 1 ล้านรอบนะ million revolution 1 ล้านรอบ so then they not count by the time. So then if you know the speed of rotation we can calculate the time for the 1 million revolution. Okay? We can calculate that. Now, what is L10? L10 is the life of the bearing. 10, this means that, like this, if you have L10, it means that they do the experiment for the bearing. Okay? So then, for L10, for this road C, to get the 1 million revolution, you will have 10% of bearing fail. Okay? And 90% not fail. ถูกไหม L10 หมายความว่าเมื่อทดลองเอาแบริ่งรุ่นเดียวกันจากเดียวนี้มาทดลองที่โหลดเดียวกันใช่ไหมแล้วก็หมุนไปใช่ไหมครับพอครบเลยการรอบปุ๊บ 10% ผ่าน 90% รอดเห็นไหมนี่คือความหมายของ L10 นะครับเพราะว่า why because each bearing do not have the same life. You understand that? Impossible. They compose the bearing composed of many elements. Every element more than 10 elements inside. So then impossible to say that we can design this bearing to this life exactly. Impossible. Okay? So then they have to use the term statistic. Okay? Okay. Can mean that by experiment for the same bearing type, for the same road. Okay? After work for 1 million revolution, you have 90% pass, 10% fail. If we have 10-50, it means that 50% fail, 50% pass. Okay? So then, now, you understand, if you say that by use L10, not L5, what will be the difference between the bearing to have the live L5 and L10? มันจะต่างกันขนาดไหนระหว่าง L10 กับ L5? So then, we can imagine that for L5, the bearing will be bigger. Okay? To support the same load for normal time. Compare between the L10 and L5. For L5 bearing, the size of the bearing shall be bigger to guarantee that they can support higher load. Okay? So then it will be what happened? More expensive. Okay? That is the problem. So then it is the standard for all the bearing in the world, for all the companies in the world, that they use the L10 and the value of C for 1 million revolution. Okay. So then you have to understand, one revolution for the motor that work in the factory may be very short time. Or for the car, for the vehicle, it will be very short time. But in the revolution not so much. Okay? But for some use, like the wheel of the airplane. Okay? The wheel, the wheel of the airplane. But in the revolution, it's been a long time. ที่บอกเนี่ยเพราะว่าล้อเครื่องบินมันใช้น้อยที่บอกมันใช้ตอนวิ่งขึ้นก็พับเสร็จแล้วก็ตอนลงใช่ไหม But for the automotive, when you use the car, the bearing support for 1 hour, 2 hours, even 8 hours all the time. Okay, so then when we look at this really small time, certainly for maybe 1 day or 2 days. Okay. So now what? We need the standard. So then do you know now how we can use it for the design? Okay? You have to based on this one for your design. Okay. Very light. all the bearing elements, okay? You subject to variable contact space with other operation. And then they are very damaged due to vector fatigue. Okay, the fatigue. The common life measure for by number of revision of engineering or number of how to use for standard address. Standard address is mean RPM. Okay, address. How many log in the RPM. Okay. Getting light. The group of number with ball or rolling bearing is one number. That 90%. Okay, you can see here. See 90% of group of bearing you will achieve or exceed before the failure when you develop. So then you have the light. Median life, average life is the 50% time life of the group. Okay? So then the median life is between 4 to 5 times the L10. Okay. Median life is mean the average life. Okay? You have to know that the L10 is conformal experiment. And we use this as the standard for the selection of the bearing. Okay. But for the average life of the bearing, we use the 50% time, 50-50. Okay? 50 bars, 50 bars. Okay. So then the median life is between 4 to 5 times of the L10. It means that if you select the smaller bearing, okay? The smaller bearing. It will not be L10. It may be L50. So then, but that bearing can stay longer, okay? 4 to 5 times of the L10 bearing of the same loop. But they have the possibility, okay, that 50% of that one will be damaged before. คิดยากนะนึกออกไหมสกอร์นี่ตัดสินใจยากนะคุณนึกออกไหม คือถ้าคุณซื้อ L ถ้าคุณพิจารณา L50 นะครับคือจากเนี่ยคุณจะเห็นในสูตรคุณมีsee the formula. So then the formula provide us the standard for L10 and contribution. But if you want to use this one for longer life, you can, and to use this one, you can reduce the size of the bearing, okay, by yourself, and use the calculation formula to determine for L50 or L50. Okay, so then you take one bearing that can have a life longer, 5 or 4 to 5 times, but the possibility that this bearing will be damaged is more. 5 times more. Okay? นี่ต้องคือผมมองว่าเป็นแม่งตัดสินใจคนเลือกแบริ่งนี่ง่ายๆนะเพราะว่าคุณเลือกแบริ่งที่ L50 เนี่ยถูกกว่าใช่ไหมเล็กกว่าตั้งง่ายแต่พังเร็วกว่าไม่พังเร็วกว่านะพังช้ากว่านะครับแต่เปอร์เซ็นต์ที่มันจะพัง 50% เนี่ยมันเยอะกว่าเพราะฉะนั้นการที่คุณไปซื้อมาจากร้าน1,000เนี่ยใช่ป่ะคุณซื้อตัวนี้มานะมีโอกาสแค่ 50% จะรอดหรือว่าถ้าคุณซื้อแบริ่งตัวใหญ่กว่าที่เป็นL10มีโอกาส 90% จะรอดโอเค so then the decision that's so very not easier for the engineer. But however, for the standard, you use L10. That it is accepted by every people, by the owner. Now, very your life formula. You have the formula like this. For experiment, the relation between the load and the life has 90% reliability. Now we have two terms. Reliability and availability. What is the difference? Availability and reliability. You understand that? สองคำนี้เข้าใจดีนะ ถ้าเราบอกว่าเรามีแบริ่งที่ใช้ได้เนี่ย 80% availability แปลว่าอะไรครับ What is the meaning? That you select the availability of the bearing 80%. It means that now we have 80% of bearing, this bearing that can be used now. Okay, in our stock, we have 80% of this we have about 80% of this bearing of this type that can be used now. Okay, but after we put it for use now, what is the reliability? How can we rely that this one will not fail? Understand that? คือเดี๋ยวนี้คือจำนวนที่มีอยู่ใช่ไหมถูกไหมมีอยู่แล้วเนี่ย 80% เนี่ยเรามีอยู่แล้วแบริ่งประเภทนี้นึกออกไหมฮะแต่พอคุณยิงมาใส่ปุ๊บใช่ไหมฮะไอ้แบริ่งตัวเนี้ยมีลายกี่เปอร์เซ็นต์เชื่อถือได้ว่ามันจะไปรอดกี่เปอร์เซ็นต์นะ then so this one reliability is L10 it means that this one we believe that 90% can be used over 1 million revolution รู้ไหมต้องที่มาแบบนี้นะต้องเข้าใจเพราะว่าเวลาคุณไปทำจะเจอศัพท์ตัวเนี้ยเยอะๆ availability กับนั่นจะสลับกันโอเคง่าย so then for experiment the formula on the log scale this is the log scale you know that okay so then we have the deadline okay between the force okay and the life that is deadline so then we have the formula like this okay we have the formula like this you understand that because when you take the log you put the log so then you can get the linear line linear equation okay now so then F force multiplied by L this one L is L3 1 over A equal to constant A the term A is the constant A equal to 3 for ball bearing and A equal to 10 over 3 okay for roller bearing okay the value of A not the same between the roller this one this one is the ball bearing we call this one ball bearing this one is the roller bearing okay if you use this bearing and A equal to 3 if you use this bearing A equal to 10 over 3 okay so then you have F1 L1 okay 1 over A equal to F2 L2 now if we conform this formula constant so we get this one now C10 is the catalog load rating okay so then you go to the standard you open you get the value of C10 so then you will get C10 multiplied by L10 1 over A equal to FL1 so then this is the design equation what you have now You have C10. Okay. Say 1, 3. Okay, more value. Okay? You go to F. They use F, L, 1 to 1. Or 1 to 1. This formula for one value. Okay? So then you get this one from catalog. Okay? You open the catalog. You have the row C. And then you have the L10. What is L10 now? 1 million revolution. Are you okay? Let me learn. Now go for the standard. The life L10 is 1 million revolution. So then this L10 is 1 million revolution. And then you have C10 from the catalog. Okay. Now, if you use different F, okay, not C10. If you get F more than C10, what will be L? It will become less. Okay? You get the formula, huh? You get the other formula. You say L. So the number is C10 equal to F L. Something like this, huh? Okay. So then L. Okay? Okay? So then now, we have C10 already. Okay? From the standard. Any kilonewton. F is the input load that you want. Okay? So then now you calculate for the life. Okay? That how many revolution you have. Okay? How many revolution you have? Okay? This one equal to 1. Because we start by 1 million revolution. 1. Okay? So then the unit of L here is the million revolution. Okay? So then you can have 2 million revolution if F is smaller than C10. Okay? But if F is higher than C10, you have L less than 1 million revolution. Okay? So then when you know 1 million revolution, you do MR. Okay? If you know RPM, the speed that you use, okay? Now you can calculate that. To complete this one, if you take 1 hour, okay? 1 week, 1 month, 1 year, 2 years, 3 years, depend on. Understand that? Okay. That now you can decide. And then you go to select or you go to bar the bearing. So then, if you want to go to bar the bearing, what you have to know first? You have to know that what is the line you want, okay, for this type of engine. Understand that? If you design one motor for use for this purpose, so then it shall be work for 2 years, 10 years. Okay? So then 10 years assumption. What time, how many long they use for 1 day? So then in 10 years, how many days you use for one year? Okay? So now you can calculate what will be the resolution that you want. Okay? And from that, you go back. Okay? You know that. You go back and then you can get the C10 that you want. When you get C10, you go to select for the catalog, right? For the C10. Okay? So then you get the value that you want. Okay, you need select. So then that we want to know now is the lines that match with the type of engine, okay? So that is already here. You can see. Okay, you have this one. The type of application. Life in kilo-hour. Kilo-hour is mean you have to multiply this term by 1000. Okay? So then, instrument and apparatus for infrequent use. Okay? So then, up to 0.5 kilo-hour or 500 hours. Okay? For 500 hours. Aircraft engine, 0.5 to 2 hours. No, 500 hours to 2000 hours. Okay. So then you get it is something that is the comment or the standard for the use of the life of the bearing. Okay, you can see that. Yeah, at the end. Machine for 24 hours service. Guarantee is extremely important. What machine? In your opinion? Machine for continuous 24 hours service. Guarantee is of extreme importance. What machine? Generator and turbine in power plant. Okay? What can? Because if this one fails, it means that your power plant cannot operate. Okay? Cannot operate. So then, what is the price of the electricity now? Okay? It's about maybe 3 baht or something like 4 kilowatt hours. Okay? So then if you take the time for change, okay, for looking for the new bearing to change all the thing, say maybe 1 month, how many money you lost for the selling of the power plant? Let's say only a small power plant, 10 megawatt. Okay? So then 10 megawatt in 1 hour, what is the benefit you have? So then 10 megawatt it means 10,000 kilowatt. Okay? 10,000 kilowatt. So then in 1 day, 24,000 kilowatt hour. Okay? Multiply by, say, 3 baht. The selling price. So then if you take about how much? Understand that? If 1 month, how much? So then this price normally, this thing, this benefit that you lost, is higher, very higher, more than your maintenance. Okay? So what they do the money normally for the power plant? You have to stop first by the time determined, okay? And then we do the change of the bearing before its failure. Okay, that is the part, that is the fixed time maintenance. Okay, but now what they do, they use the monitoring technique, okay, by vibration measuring. Okay, when you see that the bearing have the symptom that show that it will be failed, it may be in the next, not more than 1 month. So then it means that you have to decide now to change this one. Okay? You have to order the bearing first. Okay? And then to stop and take the change. That may take only about 2 or 3 days. Okay? Not to waiting for 1 month. Now, we have also this one, machine for 24-hour service, 50,000 or 50,000 kilowatt hour. Okay. This may be the, normally this may be not the power plant, this may be the petroleum plant something. Okay? Because they can stop, but they not make any damage for the price. So then, this is how what you can use this table for the determination, okay, for the machinery, that what will be the time that we need, okay, time that we need. Now, when you know kilowatt hour and you know RPM, so then you can know now that what is the year, okay, how many years that this will be used, okay. Now we need something that we call load factor. What is the load factor here? This is something the same as safety factor. Okay? That's safety factor. Type of application. If you use the precision gearing, you know what is the precision gearing? ก็คือเป็นเกียร์ที่มันใช้ในงานละเอียดมากหรอกนะคือจริงๆแล้วเกียร์พวกนี้จะทำจากthis gear you make it from really maybe stainless steel or titanium steel, something that you not wear so you not worn, okay? For wire or the precision, okay? Movement that you want, but compared to this one, for machine gearing, okay? So then the load factor become higher, okay? So now basically with the moderate impact, we have this one. Okay? So then this is something, the safety factor that you can multiply this one to the load that you apply. Okay? And then you do the calculation for the line. This one is 30 load, 30 CO. So then the first thing, so then in the catalog, okay, I go to show you the catalog. This is the catalog. So that this is the catalog that you can have this catalog in the textbook. Okay? So then you have this one, normally you have this one CO. You have this one C. Okay, this is the ball. This is maybe the bearing number. This may be the ISO. Okay? So then for the model of the factory, have to link to this number. นะครับปกติแล้วถ้าเป็นของบริษัทใช่ไหมแต่ละเจ้าก็จะมีโมเดลที่ก็ไม่เหมือนกันนะมันมีแต่ชื่อเป็นอันที่เชลล์ลิงก์to this number. Okay? So then this now is the sample. So then what you have the diameter, the D. Okay? The big D is the small diameter is the ball diameter. Okay? This is the ball bearing, ball diameter. D is the bearing diameter. Okay? Outside bearing. B is the width. Okay? The width of the bearing. And then I think this is the one. Okay. Prefer shoulder diameter. You know that? For the shaft. Okay, so then if you have the shaft, you learn the shaft already, you have the shaft. Okay, so this is the shoulder. Shoulder diameter. Okay. For the shaft, for the housing. Okay. So then, millimeter. Bearing weight. Okay, bearing weight. And then you get the basic static load C. Dynamic load CO. Okay. Dynamic load C. Okay. So then, when you first start, you have to select it from C first. CO first. CO first, huh? Because it means that if your shaft support the load, one load for one bearing, higher than this, is not preferred. Okay? Because it can make the deformation permanent, okay, to the bearing. Okay? Because the definition of CO is the load that will not cause the deformation greater than something that guarantee for the elasticity. Okay? So then if you calculate one bearing support of the shaft, you get the load something higher than this one. You have to select some number higher. Okay? You guarantee that. Okay? Now, after that, go to here. Okay? So then, suppose that you select this one. So then you get C equal to 5.25. So then you can put 5.25 here. Okay? That is the secret. Now you put your load here. Okay? So then what you get now? You get the line here in the revolution. Okay? If you found that, this line is to this. You want to repeat this line, what we can do? We increase the size of the shaft. Okay? Increase the size of the shaft. So then, now, load maybe becomes smaller. Okay? And then you can get like okay? That depends on. Okay? This is the design technique. Okay. You will have one problem about this. Okay? And you post this one and the second homework for you. Okay? Come back to it. Now, okay, this is the formula that we need. I think I showed you already on the table or the board. Okay. Now, the rated cycle L10 is 1 million revolution, except state 2Y in manufacturer's catalog. Okay? But if they say nothing, this will be only 10 million, 1 million revolution. That is the standard for every company. Okay? Except that there is normally you have to be careful because you will be for the same company. Okay? Only maybe some model that L10 not need this one. Not every, because otherwise you got the difficulty for the selector to choose. Okay? Maybe just only some special type of value. Okay? That have to differentiate. So then be careful. Now this is the dynamic analysis. So then R is the derivative equal to 1 minus T divided by NTDF. R is the reliability. It should be in percentage or the from 0 to 1. Okay, something like that. T T is the interval of time you want to use it. Okay. MTBF is the mean time to failure. It's the time to failure means that the time between two maintenance. Okay, I explain you a little bit more for this one. You may have, if you go to slightly higher, you may have MTBF and MT. Okay? This is the same thing, but this is mean time between failure. This is mean time to failure. What is the different meaning? This is the mean time to failure. It means that when it fails, we change it a little bit, replace it with something. Okay? But this mean time to failure, it means that when it fails, we do repair and bring it back for use. Okay? Like a motor. Like a motor. For the bearing of the motor. If the bearing fails, this mean time to failure. Because you change, you take the old bearing out, okay, and then replace by the new one. But for the motor, okay, when the bearing fails, the motor cannot be used. Okay, it shall be in maintenance. But the maintenance of the motor is MTBF. Because we replace the new bearing and then we can use that motor again. Okay? But the motor can be maintenance by another thing, change the bearing to do the rewind, okay? Or something like that. Okay. So then you understand it's going to be the same thing. Now T, okay. So then equal to E minus. This is the time. So then normally MTBF comes from what? It will come from your data. Okay? Or come from the big data may come from the catalog of the manufacturer. They say that you have to change this one every 2 years. Okay? You change this one every 1 year. Something like that. Or it may come from the company experience, your company experience. That after a long time of use, okay, if you make the record, you can say that what will be the mean time to use. Okay? That you can state that for the change of the part. Okay? Okay. So then depend on this T is the real time. So then if you get this one will be something that will be fixed, okay, for one machine. So then you play between R and T. You can select that you want this reliability, and then you can get the time that you want. Okay? But if you fix the time, you get that what will be the reliability of this part that you can leave it to work. Okay? That depends. However, this one, as I know, for this case, for the simple design, for the selection of the bearing, we don't consider this. Okay? We just follow the standard technique. Okay. But this normally, I know, it may be sometime I can involve in the work for the, it shall be the work for the cement type company or something. Okay? That they want to consider the reliability of all the machine in their factory. Okay? So then that the work that have to do everything. The work that you have to do for one bearing, something like that. Okay. This is the thing that we this equation, not used only for bearing. Okay? Not used for bearing. Any element, if you know this one, okay, you know the time that you want to use, you can determine the reliability of that element. Not necessary to be only the bearing. It is the formula comes from reliability engineering. Okay? Not from the bearing. Not necessary. So then, for this one, it's not important now. Okay? It becomes later. In the case that your company need to do something about the reliability. Because sometimes the company say that, okay, now we want to guarantee that the reliability of our machine in the shop is something more than 99.9%. เดียวนะดีนะผมเคยไปทำให้ใครจำไม่ได้เขาก็บอกว่าเนี่ยเขาต้องการให้โรงงานเขาเนี่ยมีรายละเอียดที่เชื่อถือได้ 99.9%นั้นสิ่งที่ต้องทำก็คืออะไรครับก็คือต้องมาคำนวณก่อนเลยว่าแต่ละอีเวนต์เนี่ยเท่าไหร่นะแล้วก็ถ้าตัวไหนที่มันต่ำกว่านั้นใช่ไหมต้องไปวางแผนต่อถูกไหมจะต้องป้องกันยังไงที่ให้มันพับขึ้นไปหรือเรื่องใหญ่คุณไปซาได้ตัวเดียวก็ไปคิดเสียเวลาเห็นแล้วNow, this one is combined with radial and thrust protein. Okay. Normally, when we talk about the bearing, okay. Normally for the bearing, what is the bearing? We support the radial load. Okay? Radial load. Okay. Only that some bearing need to support for the thrust load. This is the case for the bearing that support the shaft. Okay? That contain the gear, not the spare gear, vertical gear. This will support this vertical gear. You have the load only in one direction. Like this. Okay? This is spare gear. You get the gear already. Okay? You know spare gear. If you mean this shaft and you have the spare gear here, the load here is only this direction. Okay? And then the load that transfer to the bearing here is only the radial direction. Okay? But if now this gear is the helical gear, you have the load this one and this one. Okay? Because the push of the spur gear is something like this. So then you have the load this one and this one. So then this load will create what? The side load this way. Okay? To the bearing. So then now the bearing support to load. Okay, you support to axial load and radial load. You support this load. Okay, so then the problem is that what is the C we have to use for solution of the value? Before we talk only about the C that comes from radial load, no side load. Okay, that is now your bearing support to load. So then we have to determine this one equivalent radial load. This is radial load by this formula. Okay, so then for the formula you have V equal to 1 in the ring rotate. V equal to 1.2 in the ring rotate. This is one complex. Okay, after that. You have some comment for self-riding bearing. Okay, only 1 to 1 formation or officially. In case of self-riding bearing, so then V is 1. Okay, whatever the linear rotate. X and Y factor come from the next table. Okay, so then you get the formula X equivalent equal to Xi VFR like this. So then in this formula now, what you do first? You know first. You know FR, you know FA, okay? For calculation for the shaft. Okay? You calculate FR for the shaft already, right? And then you know V. Okay? You know V. Because you will know that what will be the rotating base? Inner or outer. Okay? The topic now is Xi and Y. Okay? So then we go to the next table. Okay. So then in this table, you get what? If I equal to 1, you get this value x, x1 and y1. Okay? If you get I equal to 2, you get this value for x2 and this value for y2. So then 1 and 2 come from this one. You get that. I equal to 1 when you get this formula, okay? But if you get this formula, you get this here. The calculation, get this one, you use I equal. So then from this calculation, you know now that you will select this one, or this one. Okay? Because you know from this one now that your I will be 1 or 2. Okay? So your I will be 1 or 2. Okay? So then it is 1. Now you get this table. Okay? This table for 1. When you get this table, it is equal to 2. Okay? So then when you apply, okay, x and y here, you apply x and y here, you get Fe. And then this Fe is the C. Okay? In the case of the bearing that support two loads, radial and side load. So you get this one. Okay? You put this Fe as the equivalent radial. And then you go to this table. You get this Fe here in this column for the selection of the value. Okay? Now, this one, this table of bearing is just from the textbook. I don't remember what this table. Okay? Just only as the demonstration. But now I provide you already key company standard. I refer that SKF and then MTN. You have that already in my course view. I put it in the course material. So you can get that for your examination, for your homework. Okay? Okay, this is for this one. This one is for taper roller bearing. This one for ball bearing or spherical bearing. Now for the taper bearing is something like this. taper value. Okay? You can see this is the taper value. So in this case, you use this formula for taper value. Okay? And then you have the definition. What is PA, PB, something like that. Okay. Okay. We talked about this already for the light selection for different equipment. Okay? So then you can see that for the normal equipment that you have, either by the motor, okay, or something, that you can apply something that for the first thing, the instrument of that for secondary use. Maybe something like this. 100 hours is a long time. Like if you have the fan in your house, not air conditioner, the fan. So then, how long that you open your fan? Okay? Maybe only the night. Okay? So then only the night, maybe 2 hours, 3 hours. So then what will be the 500 hours? Okay? You need to how many days, something like that. Okay, these are the safety factors that we have to use. That's good. Okay. It is something. Okay. Normally, if we talk about the fan, the house fan, okay, the load is constant. Okay? When you open the fan, but however, the fan may be changed into 3 steps, like normally 1, 2, 3, okay, 0, stop. Okay? But what changed? The load change or not? For the step 1, 2, 3, in the other fan, change or not change? ครับพัดลมที่บ้านคุณเนี่ยตอนนี้มันจะมีทั้งหมด3 ช่องนะ1 2 3มีกด1 2 3เนี่ยโหลดของพัดลมเปลี่ยนมันหมุนเร็วขึ้นใช่ไหมเปลี่ยนไหมเปลี่ยนนะแต่ต้องเข้าใจนะเดี๋ยวต้องมีระเบียบคุยก็เลยคือพอพัดลมหมุนเร็วขึ้นก็คือมันส่งลมให้ออกมาแรงขึ้นนั่นแปลว่าโหลดที่ลงนะครับที่ถูกมากระทำต่อใบพัดจะสูงขึ้นลมถึงออกมาได้เร็วขึ้นโอเคป่ะนะครับถ้าคุณหมุนที่โหลดกับโหลดต่ำสุด3เล็กๆน้อยๆเนี่ยพัดลมจะช้าใช่ป่ะพัดลมก็ออกมาเร็วใช่ป่ะงั้นโหลดที่พัดลมส่งมามันน้อยงั้น3 สเต็ปเนี่ยโหลดไม่เท่ากัน so then in one day it depends on the weather okay so then this day maybe you open 1 okay today you open 3 okay next day you open 2 something like that so then you have many load that you use so then how can we determine the damage accumulation okay really it is not mean for the fan not necessary the fan is something necessary but about the machine that you use in your factory okay so then you may have some part some machine that you have to variable load all the time you understand that for the factory normally for the machine that you use in factory the load not change so much normally in one day we work at only 1 load the same all the time it may be work like that for a month for 2 months okay Only that when you change the what production, then you may change the load to your machine ระวังนะครับเพราะว่าปกติเครื่องจักรเราใช้ในโรงงานเนี่ยมันจะไม่เปลี่ยนเลยนะมันจะไม่เปลี่ยนเลยนะครับแต่ว่าเครื่องจักรที่มันไม่เปลี่ยนเนี่ยเพราะว่าปกติแล้วไม่มีเป็นไม่ได้นะจริงๆถ้าเครื่องจักรแล้วโหลดเด้งขึ้นเด้งลงไม่บางเครื่องจักรทั้งวันเนี่ยใช้เราใช้โหลดเดียวเนี่ยเป็นปีก่อนจะเปลี่ยนโหลดหรือเปลี่ยนโปรดักชั่นแล้วyou have to understand this one okay so then for the drainage accumulation it's not anything that will happen all the time okay not frequently for the fan that I talked before that it may be changed more than the machine perfectly now in that case what you can do this is the damage D this is the damage accumulation it comes from the damage comes from S1A multiplied by L now is the time that you use and F is the load applied A is the same meaning A equal to 3 for bearing cylindrical A equal to 10/3 for the spherical bearing. So then, if you use F1 multiplied by L1 for some time for this load, then you get this calculation. Okay? And now, the definition is equal to this. So then you get the relation when the bearing run to failure. Okay? Run to failure. Under FE1 and FE2, okay. FE equivalent load, E. Okay. So then you get this formula. Calculation that sigma Li over Li equal to 0.1. And then when this value summation, okay, you get the value that the total equal to 1. It means that the lifetime go to the end of the L. So then that will mean that the failure will occur. Okay? So then this calculation is just only for the determination of that. Now, what is the status of our machine? But normally, before, as I know, because I work with many companies for the maintenance, this formula nobody know. คุณให้โรงงานมาแล้วไปช่วยเขาทำโรงงานมาสูตรเนี้ยไม่มีใครรู้จักนะครับแล้วก็ไม่มีใครใช้ด้วยเพราะว่า if we do this by using manual to work hard work okay so then that time that we don't have the lock the data locker computer we have not have this one but nowadays it's possible why because we have the data locker that can collect all these things, okay, and make the formula and make the calculation for us, okay, and then can warn us that now the calculation is now like this, is in the time that you have to consider for the replacement something like that. เดี๋ยวนี้เป็นไปได้นะแต่ก่อนไม่มีนะ So then this one now if you go to work in the factory, that is fully automation with the computer, okay, and the program. You may see this. Okay, possible. But before ever, it takes time for the collection of the data like this. Okay. Okay. So then this is all about the bearing. Okay. Now I put already the homework for the spring, for the spring. Okay. So then the due date is next Monday. Okay. You submit your homework here. Okay. Next Monday for the spring. And then this week I will post the second homework for bearing. Okay. And the due date will be next one. After next Monday, okay, 1 week more. Okay, and you will have only these two over. Okay, only these two over, not more than that. But your final, your final. I repeat again. You will have 5 problems. We learn 5 topics. We learn spring, we learn bearing, we learn screw, we learn belt, we learn brake. 5 topics. So you will get 1 problem for 1 topic. Okay. For me, I estimate. I will for me for the problem, I will try that. Hopefully, how you can finish for at least 3 problems from 5. Okay? I don't say that you have to finish all 5, but you can do it, you can. Okay? You do everything. Okay. Otherwise, you have to finish only 3. That is good enough for me. You have to understand that. Don't ask me that the problem is hard or not. Okay? I will not do that. เข้าใจนิดนึงผมไม่มีเหตุผลที่จะออกข้อสอบให้มันได้คุณทำไม่ได้เดี๋ยวนะครับพอออกไปคุณทำไม่ได้ก็ไม่ได้แปลว่าอะไรสักอย่างนะทีนี้ถ้าออกข้อสอบให้ทำไม่ได้นะครับเป็นข้อสอบที่ออกง่ายที่สุดนะออกยากๆออกให้ทำไม่ได้นะแล้วก็ส่งง่ายเลยแต่ว่าผลลัพธ์มันไม่ได้ขึ้นมาแล้วได้สูงหมดทุกคนก็แปลว่าคุณได้4 คนคือคุณได้เต็มร้อยหมดทุกคนก็ต้องได้4 คนเท่ากันไอ้ที่ยากก็คือว่าทำยังไงให้คะแนนคุณไม่เท่ากันตามความสามารถนะถือว่าคือตามความสามารถ